Broadcasting from Studio 202 at the Springett Technology Center in Navasota, Texas. It's NOV Live. Now, here's your host, Michael Gaines.
Hello and welcome to NOV Live. I'm Michael Gaines and glad you're joining us today as we have round two of our conversation today talking about engineered composites for offshore wind. If you were joining us last week, you may have seen that we succumbed to technical difficulties, as do all of us, especially in this last year of many working from home scenarios, where in our case, we're actually in our studio, but happen to have one of those unfortunate fiber line cut incidents. So I do not wish that on anybody. So for those that are joining us today, thanks for jumping back in the saddle with us as we have our conversation with our expert here. So before we jump into that conversation, want to go over and bring in Shelby Dumaine. I know last week, Shelby, you just started, welcoming folks and letting them know how they could be part of the conversation, and then things froze. So kind of knock on wood here. Let's give it another go here.
I know, and part of me almost wanted to pretend like it was on purpose. That way we could line up with the Floating Wind Solutions event happening in Houston this week, but didn't. But, it worked out anyways, and so we're happy to be back here. And if you at home or at work are watching the show right now, feel free to comment and let us know where you're watching from. So I've been looking at the comments already, and I saw India. I saw someone from Miami tuning in, maybe even France. I don't know. I saw bonjour. I assume they're in France. They could be anywhere. But that is the best way to get in touch with us during the show is by commenting, and that will come in handy because we actually do a live audience Q&A at the end of the show. So if you're listening to the show and you have any questions for our expert on floating wind or offshore wind at any time, go ahead and comment those. And like I said, at the end, we're going to do a live Q&A. So we're going to get to as many questions as we can. So during the show, your best bet to get in touch with us and get those questions answered is by commenting. And then after the show, say you want to watch any past episodes, you can do that actually at nov.com/live. So I'll have that URL on the screen, but it's nov.com/live. You can watch any past episode. And if you have a question on those, it's a little different. The best way to get a hold of us if you're watching a past episode is actually by emailing us at socialmedia@nov.com. We still have, all of our experts here. So if you have any question, we want to get it answered, and so we can do so if you email us there. But again, the easiest way for today, if you have a question on today's live show, is just by commenting it. So I look forward to seeing everyone's comments there. And before I throw it back to you, Michael, it's it's time. Normally we call this Rig Geeks, but this week it's a little more of a wind geek, I think, question. Where I ask you a question. So it's time for Rig Geek or Wind Geek Post of the Week.
Rig Geeks Post of the Week.
All right. And this question, I think this also will kind of lend itself if we have any maybe aircraft, airline nerds. I might be looking at Michael when I say that, but if we have any other aviation fans watching. Today we're going to have this question on screen, and let us know in the comments if you think you know it. But we're asking, what is the percentage by volume of composites used in the Boeing 787 Dreamliner aircraft? It's a special. It's one of their newer ones. Michael, do you have any guesses?
I'm always a fan. Actually, I do know this because I am an aviation fan. Sometimes I feel like I need a neck brace because my head is always up wherever I'm walking. I'm always looking. My head's in the clouds. So but I don't want to give the answer away. I'm pretty sure my answer is right, but I'll let our viewers toss in some guesses. But I think they'll be pleasantly surprised. I'll say that.
Yeah, I look forward to seeing those guesses in the comments. So if you think you know, go ahead and put your guess for that Rig Geek or Wind Geek question this week. And like Michael said, we'll reveal it at the end. So I look forward to seeing everyone's guesses.
All right. No, sounds great. Thanks, Shelby. And one comment that Shelby did mention is that NOV is participating in the 2021 Floating Wind Solutions conference happening this week. So if you were able to be a part of that or have colleagues that were, hopefully you're able to stop by the NOV presence there and talk to some of the friendly folks manning the booth there. So speaking of friendly NOV personnel, we actually have one with us that's our expert today. So again, we're talking about engineered composites for offshore wind and have the pleasure of bringing in Tom Byrne, the Director of Sales for Fiberglass Systems, or FGS. So Tom, thank you for joining us today, and for our world travelers that are always pining to get out there, where are you joining us from today?
Hi, good morning, Michael, Shelby. Hi all. I'm joining you this morning from London.
All right, great. Well, I've been once, hope to come many more times, as I know the world is rearing to get out there. So so let's go ahead and jump in. Tom, so first question for you out of the gates here. You know, we're talking about engineered composites for the offshore wind space, and you know, one of the questions I had, and I think some people might have as well, is you know, are composites new, especially in use and application? Are they new to the wind industry?
So, well, firstly, thank you. It's great to be here and have the opportunity to talk about our composites. It's really exciting for us as a business. You know, we live, we breathe, we love composites. So, NOV is is truly the largest manufacturer of composites. For the offshore use in this industry. So, we supply and we have a footprint globally. But we're not just offshore rather. So just briefly, we're also in the marine market, chemical industrial market, oil and gas market, and the fuel handling market is a huge part of our business, particularly in the US. So we're manufacturing piping systems, structures, holding tanks, pressure vessels, all backed up with our global service network and field service. So more information, of course, available on our website. So we've been manufacturing actually composites since the 1960s, and we have case histories offshore since the 70s. Now, of course, maybe offshore wind wasn't around then, but listen, it was offshore doing a job and doing the same job that it does for for modern day renewables. So these products, they're not new by any means. They're well tried and tested in these harshest environments globally. So you saw that image there, that's with our floating image, and quite poignant. We talk about it as you mentioned, as Shelby mentioned, with the offshore conference going on this week, in Houston. So we're supplying into this market, also the substation market, fixed, as well as the wind turbine installation vessels also. So early engagement is probably a crucial part, for using composites in this market. As with so many other markets, metallics can be the product of default, can be the choice if you like. But if we're talking to truly get the benefits from composites, we want to be engaged early. We want engineering companies, operators to come and talk to us as early as possible. So designing with the right materials, with the right dimensions, right pipe centers, right secondary support centers for our structures, etc.
Right.
So that's quite important. So I suppose one thing just to mention, I'm sure as everybody does know, that turbine blades, of course, are made out of composites, but that's not a space that NOV fiberglass systems are in right at this moment.
So maybe one of the questions, I mean, when you're looking at offshore wind engineering opportunities, there are certainly many materials that can be looked at and solutions. So when you're looking at the composites specifically, when you and the team are approaching approaching the space to provide solutions for customers, what's the job that using composites that's trying to be done? The job to be done, so to speak. What are we trying to achieve?
Okay. Well, it's as mentioned. Well, these our products have been used for many years offshore, and they're basically doing the same job as metallics, simple steels or corrosion resistant alloys. But we do it better. So what we're doing is we're taking, of course, the products we're offering, they're safer. With composites, they're engineered durable products. They're not a lightweight, flimsy thermoplastic product, if you like, that's going to can suffer from UV or aging and fracture, etc. So these are truly engineered products, that and in some cases are stronger actually than steels. Some of our hand railings, our gratings, our wind walls can take tremendous loads. Likewise with our piping systems, quite high pressures. So they are doing very much the same roles, if you like, but as I say, just better. So with our piping systems, we're looking at critical services on some of these offshore platforms, cooling systems on the substation, to keep those generators and to keep the keep them cool. Firewater systems, again to protect the structure. Our gratings, our handrails, our ladders, very important to so they're as I say they're lightweight, but plus they're not going to suffer from any sort of corrosion. We just do not see corrosion with these products, and that's a huge advantage because the products they're reliable, predictable, and again that's very important when you're in that environment, particularly if you're moving into some of these these applications that are probably normally unmanned. So again, there's a big importance there. So
yeah, and especially in this graphic that we were looking at. I mean, the railings and other structures. I mean, these are not low use or low impact type of space. I mean, this is high touch, high impact, and high criticality in terms of the safety. So to be able to have that the benefit of no rust, right? No corrosion is really key. And yeah, I agree. The dual benefit of having that weight saving certainly makes a huge difference. So maybe I'd like to shift a little bit and talk about maybe some real world applications. So we've been kind of talking, not necessarily conceptually, but maybe more high level. So I'd like to maybe move into a more tactile type space and talk about projects that composites have been used for, and maybe if you could explain a little bit on the background as to why composites were chosen.
Yeah, certainly. I think as we just mentioned, you were just touching on rust and where does rust come from? It comes from these salt laden environments where these products are and these projects are sitting, particularly around to off Brazil, to West Africa, to off Northwest Australia. Some real sweet spots there for corrosion. So we have many projects we've completed within those areas. We're in the renewable space, of course. That market is growing, but as we say, the product doesn't know where it is and where it's sitting. If it's sitting on a traditional oil and gas platform, or if it's sitting on a renewable platform, it's still doing that same job. It's carrying fluid safely. It's protecting the asset, and it's allowing people to walk to work on these and to maintain. I think particularly we on screen now we're showing some of our case histories of projects we've successfully completed, and again a lot of these projects, as I just touched on, are what we call NUIs, or normally unmanned installation, where access is is less frequent, maybe annually. But what these companies want to do, they want to safely send a team of guys out there to maybe go and repair the turbine, the gearbox, to monitor some of the equipment on here. But they want to go out there safely. They want to come out with the walk-to-work vessel, walk on board and just get on with their work. Whereas if they're using metallics, firstly they need to maybe go and do an inspection. How are they holding up? Are they secure? Are they safe? Making sure the pipe work is not leaking, and again causing some issues, some secondary issues that could cause. So we have quite an array of projects there, and we've just shown you some examples there, and that's growing all the time, right. As you'll well know, and I'm sure the listeners will well know.
Right. So, speaking of listeners, for those that have just joined us, we are talking to Tom Byrne, who is joining us from London, and he's the Director of Sales for Fiberglass Systems, and we are talking about engineered composites for offshore wind. So if you have questions for Tom, today is your day, because he is here and ready to answer your questions as we move into our Q&A portion in just a little bit. But feel free to put your questions in the comment section, whether you're watching us on LinkedIn, Facebook, or YouTube, and we will be sure to get to your question or in as many questions as we can before the end of the show. So again, talking about offshore wind engineered composites. So feel free to join the conversation. Shelby is starting to compile the questions now as we speak. So looking forward to that part of the show. So Tom, I want to move into a question that I think on the face of it may stoke some passionate responses depending on where you're coming from. But I know that you all are definitely a data focused team. So my question is, when we're looking at how composites compare to the metallic equivalents in application, especially when we're talking in the offshore and offshore wind space, help me understand, how that works, because I know that the initial response from someone could be, well, it's steel all the way, and that's the end of the discussion. And certainly, I think there's some people that may have started there, but through conversation, with experts such as yourself, have maybe been able to expand some of those perspectives. So could you share a little on that?
Yeah, no, absolutely. Again, great, really good question. And as you quite rightly say, as quite rightly said, that often, yes, it's the metal is default, be it a carbon steel or be it a CRA if we're talking piping systems. And we do regularly have clients coming to us, and particularly more recently, the price of materials has been escalating, and particularly with steels and alloys have been, there's been a tremendous increase in the cost of those. But even going back a year, 2 years, for 5 years, the cost of these materials are greater than than our composite piping products. So that's immediately we can sit there and say, well, hey, this product can do the same job as you want the product to do, but also it's cost effective. Other benefits, of course, is when we're installing, because these products are so light, maybe 1/6, 1/3 the weight, you're using less mechanical equipment to install the products, and again, so that's going to speed up your installation. Our jointing systems are, while specialized, again, they don't need maybe the ultrasonics for testing or radiography testing. We don't need painting, coating, etc. So again, your install time is that much quicker. And equally with structures, exactly the same. We have these lightweight structures, so they can be manhandled into position. If we require some modifications, it's so easy to do offshore with handheld tools, battery operated tools. And again, you're not creating sparks, you're not creating hot work concerns, with these products. So again, there's some real benefits there. We already touched on the fact that these products just do not corrode in these environments. That's a real benefit. Mm-hmm. And I suppose another large benefit, and one we're extremely proud of, and as mentioned at a previous NOV Live event where we talked about our fiberglass systems, our CO2 footprint and lower emissions. And again, that's tremendous value, to the project, to the client, and of course to the environment for all of us. So composites are there. We know they work. They've proven they work. We have those case histories for 40, 50 years.
Right.
And as I said, we know that they're the greener choice. So interesting, a couple of slides you just put up, with our floating offshore wind projects, and there we go. Thank you. So just right on the top of there, you'll see those tubulars just to the right hand side, and running off to the foreground. There's hand railing, there's access structure there to get from corner to corner to get to the turbine, to get from the landing access. So that's something again we're looking at, and we can offer these products in composite. And again, for that very reason, because these projects are going to be inspected, at maybe 12 months, maybe 24-month periods. People want to go on there and walk along these walkways with absolute confidence.
Right.
And again, that's what our composites can give you.
Right.
And just we're talking here about 60 odd kilos, 150, 160 pounds per linear meter for 3 foot. So we're not adding a great deal of weight. And again, with metallics here and with the rollout of these floating, particularly floating wind, there's going to be so many units required. There's so much steel required for structural steel. So we're just trying to manage that supply chain and take out steel where we can, and that's just going to help and it's going to benefit everybody.
So I know one of the other components that also benefits customers and those that are looking into utilizing the composite solution is really having that confidence and knowing that these solutions are being developed and designed to international standards. No, that's a key component. I'm sure gets asked early on in the conversation many times, if not almost at the beginning. So, what are some of those standards, and how does that play a part in the overall design process?
Yeah, no, absolutely right, and as well, it's crucial. It's crucial to give customers, clients, that understanding and that belief. I suppose that third party. Assurance that they're going to get by our products being tested. We're continually testing our products, our piping systems, our structures. It's ongoing. We have ongoing testing regimes with our products, be it for testing for pressure, temperature, load, structures. So that's they're absolutely critical. So there's lots of ISO standards in place, ASTMs, ASMEs, NORSOC over here in Europe, DNV standard, BSENs. So we, our suite of projects, are tested, fully tested and fully compliant with these products. So we're talking pressure testing, load testing, fire testing, high and low temperature testing, salt testing, UV, electrostatic, discharge, painting, QA, QC, you name it. It's a full-time job. Testing these products, and then probably more specific, if you like, if we're talking about projects in particular parts of the world where where we want, maybe we've got some high wind loads, we got some high wave loads that some of the products might see, or in seismic areas. And again, they're all loads that we're capable of designing with and proving, to the EPCs, to the clients that, hey, we can design to these, we can handle these, we meet and match these standards and fully compliant. And that compliance question is absolutely key. And sometimes it's maybe not quite understood, but it's really the responsibility of these EPCs and end clients to really delve into these standards and say, hey, with these companies that are saying, yeah, we're fine, we match this, we match that, but are you really? Do you really? So that's a very important point is to make, with this testing.
Right. Well, I want to kind of start to round out our conversation, really talking about one of the key aspects as well, which is the support that you and the team are able to provide, not only locally but globally, and speaking of the global offshore wind industry. So how is NOV and the team able to help provide that needed support for those that are engaging with you and others?
Yeah, no, indeed. And as I said right at the beginning, we are probably, we'll be the only truly global composite company. We have facilities all over the world, North America, South America, Europe, Asia, Middle East, you name it. So we have those manufacturing facilities in those locations. We also have, well, I've got a lot of colleagues based strategically around the world, and again in these probably traditional centers, but also in the up and coming renewable areas. And we talk about up and coming renewable areas. We're talking, of course, coastal areas. So off here in Europe, the west coast. So from Scotland down the west coast of Ireland down to France. In Asia, off Taiwan, Korea, the U.S., both sides of the U.S. So we where we don't have FGS personnel stationed, what we have is our global service network partners. So these are companies that are the whole stock of our products. They know our products like we do. They've generally been with us for a long time. As I say, the stock of material, our adhesives, our tools. They've been trained, they've been certified by ourselves, and they're there to support projects, be it a retrofit, an alteration, or even a repair if needs be. So that's how we offer. I think we're pretty well placed to support our products globally.
Right. No, that's great. Yeah, and I think that is certainly key, and one of the advantages that I know the team is proud to be able to offer. So no, that's really great, and I know that folks that are watching again either at home or at work, we want to be able to give additional resources and ways to connect. So for those that would like to see a web page that is fresh and new and ready, for those that want to get some more information, you can head over to NOV.com/offshore wind, and there you can read more about some of the offering there in that space. Or if you have a question or specific question and want to get in contact with us, a simple email to fgssales@nov.com is the way you can get in touch with folks like Tom or others on the team, and they will jump right on it and get right back to you. So I know that for many, they have some questions that they wanted to get answered, not later, but right now as we had our conversation. So with that, Shelby, I know that I saw your fingers type in pretty quick over there. So have a few questions from folks that were watching for Tom.
We sure do. Yeah, I have some great questions. Actually, this first one comes from William on LinkedIn. Tom, he was kind of starting the conversation talking about end-of-life management for these composite materials. So I was wondering if you could talk to that, or also the lifetime of these composites compared to other alternatives in the market.
Yeah, that's certainly a really good question. Thank you, William. It's as you say, it's something we're very conscious of. So there's experimental, I suppose, methods at the moment looking into how we can maybe strip the composite. Of course, the composite, as you well know, is two products brought together to make a stronger product, if you will. So with our glass and our resin. So there, as I say, there is some work going on to see how we can strip the resin and where we can reuse the glass. So that's in its infancy, and I think over the next 5-10 years that's certainly going to become more efficient, and that's something that we'll be able to use and able to offer. for the moment, I'm probably going back. What we just said is that we're talking design life in some of these projects. 40 years. We have projects in operation for 20, 30 years. Well, actually, some closer to 40 years. So from that point of view, we're not looking to reuse, to recycle as much material as you may expect. But what we do is within FGS, we're looking to with manufacturing offcuts and such like, is that we reuse those items, and they can go back to be recycled into park benches and bollards and those type of things that you'll see in your local park. So we're quite proud of that that fact that here in FGS that we're zero to landfill when it comes to our products and our manufacturing methods.
Mm-hmm. Oh, that's really excellent. And this next question comes from Sashu on LinkedIn. And he has this, and I'll say, I'm not even sure if you can for sure say this, but I have a follow-up question for it. He wanted to know what is the largest bore of piping we've done in composites so far. And I maybe wanted to add on to that and say, can you talk a little bit about how big we can go with composites in general?
Yeah, again, another great question. The diameters are growing all the time. So talking, as I mentioned right at the beginning, we're in lots of different spaces, and our chemical industrial guys can offer piping up to 3-4 meter diameter. So really large diameter for onshore municipal those type of projects. Offshore, we're talking 60-inch, 1.5 meter diameter. And that's these are for these bigger FLNG projects where you need a lot of water when they're regassing to convert the liquid gas back to airborne, if you will. So those sort of diameters. Onshore, much bigger for sure. Offshore, 1.5 meter diameter is the largest we offer at the moment.
Yeah, wow, that's awesome. And I have another question. I think you talked a little bit about maintenance, but can you dive into that a little bit more? And the question specifically is, how does maintenance compare with composites to metallic alternatives?
Yeah, and absolutely. I think, as you say, touched on it briefly earlier on. As we said, particularly in that sweet spot, if you will, around the equatorial areas, and something that was described to me, a real issue in some areas where you get this, that salt-laden environment. So you got it's coming up, being deposited on metal, be it piping, be it steel, be it handrails, structures, etc. And then when it doesn't rain in these areas, of course, it's not getting washed off. So then it has a real opportunity to attach to start eating away and start doing its nasty business. Whereas with composites, as I said, they're completely inert, so there's just no effect whatsoever. So we may see a little bit of effect with UV with the products, and we test our products uncoated, but then we also test the products coated. So we're painting these products to seal them, to protect them. So from that point of view, it is really, the maintenance is absolutely minimal. Of course, we do have some steel supports in our piping and steel flanges on our structures. We're going to have steel hold-down bolts or fixing bolts. So they need to be checked periodically. And again, we have information that we can share, to talk about those maintenance regimes and how to, look after the products. But certainly, that's all we're looking at. So from that point of view, it really, again, as mentioned, we're talking, we're designing these products for 20 plus years, and we're expecting, to see 30 plus years, before we actually need to start maintaining these products, if at all.
Mm-hmm. And I think that's you almost perfectly segued into my last question here, and I want to ask, you've mentioned 20 years, projects 40 years. And that's what we're designing these to last for. How is that proven? I'm curious. Can you talk a little bit to how do we know that? How do we design for that?
Yeah, absolutely. So again, back to one of the previous questions, we talked about international standards. So within those standards, they dictate design lives. And then from that, and we're using ASTMs or ASME as part of ISO to test. So we can do testing on our products that can be extrapolated, to these, for 20 plus years. So, and as I say, that's an ongoing process. We're continually testing our piping systems, our pipe, our fittings, and also our structural products as well. As I said, so we know that we're continually complying with those international standards. And as I said, we keep those graphs and those charts up to date, so we know we're getting a good product time and time again that will last the test of time. I suppose just on that note, one thing we're currently working with a company down off West Africa where we've had products installed for 21 years now. The asset was designed for 20 years, but they're looking to extend the life, and they've come back to us and say, hey, how can we prove that your products will last more than 20 years? Well, first thing is, they're already 21 years old, so we know they are lasting. But we're looking to carry out some some further analysis with those guys, so we can say, yeah, you know what, it'll last another 5 years, 10 years, or maybe even longer. So that's ongoing, and then again, that just gives tremendous confidence, to us and to our end users, that they know these products have been used and are still fully in operation after all this time.
That's awesome. And I want to thank our audience for sending all those questions. And I think for time, we're going to wrap up the live Q&A here. But if you do still have questions, if you're watching right now and we didn't get to them, still feel free to comment them. We can have, some experts there in the comments over the next day or so. But after that, if you're watching this maybe next week or further in the future, if you have any questions for us, you can email the show at socialmedia@NOV.com, or we also have an email specifically if you have questions on composites. That is, we'll have it up on the screen. I didn't memorize it. There we go. FGSsales@NOV.com. So if you have a show question, you can send it to us at that social media email. But if you have a question specifically on composites that you want to get directly to the experts, then it's at FGSsales@NOV.com. And now I did want to get to that Rig Geek question that we asked, or Wind Geek in today's case, that we asked at the top of the show. I do want to give props to Harrison on LinkedIn, who got the answer right. We're going to ask that question one more time, and then I'll reveal it. But we asked, what is the percentage of by volume of composites used in the Boeing 787 Dreamliner aircraft? And like I said, Harrison on LinkedIn, you got it right. The answer to that is 80% composites,
That's right.
Which is pretty great. Pretty excellent.
That is correct. And another fun fact for you, for those that are aviation enthusiasts is the word I like to use, that the 787 was the first large commercial airliner to use a composite as its primary material for the airframe. So there you go. I camp out there all day long. That's all I got. But it's interesting. I mean, the uses for composite, aviation, and of course we're talking about offshore engineering. It really is a game-changing application and approach to these types of solutions. So appreciate the insight there, Shelby, and certainly appreciate you, Tom, for joining us today and sharing the insight there. It was really beneficial. So look forward to more advances and items to come down the line.
Yeah, you're very welcome, Michael. It's been a pleasure. It's been great to be here and to share our knowledge and some of our experience and with you and with everybody. And again, just that that question as you just mentioned with the Dreamliner, we all jump on there. I did a few years ago when we could fly, with my family. With absolute confidence, you go in there and you fly halfway around the world, and yet you've got you got some engineers or you got some end users who've got some concerns about using some composites offshore, for quite simple systems, also some critical systems. So if we have the confidence to put our lives in the hands and go and fly around the world, let's use more of these composites offshore, and it's only a good thing for us and for the planet. So thank you very much indeed, and it's a pleasure to be here.
Thank you, Tom. And want to thank you for joining us today here on NOV Live. As always, if you would like to catch up on any of our previous conversations, feel free to head over to nov.com/live, where you can hear this and many more conversations from NOV. Again, we want to thank our guest, Tom Byrne, who is Director of Sales for Fiberglass Systems here at NOV. I want to thank Shelby Dumaine, Paul Dufio, and Wei Han Lin for helping us with today's show. I'm Michael Gaines, and on behalf of all of us here at NOV, thanks for watching and for listening, and we'll talk to you again next time.